So, can you see my screen?
It's coming.
Soon.
Okay, perfect. So, thank you very much for being in this webinar. Is the second webinar of Blue Cloud Ocean Observing webinars. Today, it's focused on the marine environmental indicators, and we will have 1 second. So I'm Alicia Blanco, and I'm speaking on behalf of EuroGOOS as Communications Officer. We are very pleased to have you here with us for this session focused on the Marine Environmental Indicators Virtual Lab and the essential ocean variables. And today we will have as well our partners and managers and leaders of the sister projects BioEcoOcean, BioGSC, and OPSI4CLIM. And today's webinar is part of the broader Blue Cloud initiative. And we have a very engaging program lineup today with contributions from experts across the several projects. So I'm going to introduce briefly EuroGOOS. So we have 48 members from 19 countries. Across our groups, we have over 140 European organizations. These are our members, as you can see in the screen, and part of our members are present here today. We have task teams that are networks of ocean observing platforms, and they promote scientific and technological synergies among European ocean observing infrastructures. We also have regional systems, 5 regional systems: the ICOoE, Baltic, NUS, EuroGOOS, and Mongoose, which is also a GRA. And apart from this, we have the EuroGOOS working groups, and recently we have launched the artificial intelligence working groups that you can check on our website and have an overview of the members. And if you are interested in joining this recently created working group, please feel free to send us a message. And you can see as well our strategy that is connected to this project. So you can scan here to have more information. And I'm going to stop sharing, and I'm going to give the floor to our first speaker, which is Dick Schaap, the technical coordinator of Blue Cloud, and he will present today the project Blue Cloud. So Dick, please.
Thank you, Alicia. Let's share first the presentation. It's coming, yeah?
Yeah.
It's coming full screen now. Yeah?
Not yet. Yes, now it's perfect.
Yeah? Okay. Now, thank you for this workshop. I think it's quite challenging, the essential ocean variables. I want to tell you very in short, let's say, what is the Blue Cloud? And Blue Cloud itself, let's say we are in 3 stages, more or less. We started with the pilot that was run till 2023. And there we looked more at the virtual research and open science concept, how to implement it. And then we had a consolidation phase in Blue Cloud 226. It was seamlessly connected to the first pilot. And during this, let's say, we expanded the virtual research environment, and also our active user base was expanded to now more than 2,500 active users. And also, let's say, several of the core services that we had developed in the beginning in the pilot prototypes, they were also more validated and more robust. Now, this was almost, let's say, we also were, of course, working with the European Open Science Cloud, because open science is stimulated by the European Open Science Cloud. And at the same time that Blue Cloud developed, there was also a new initiative from the Commission for the Digital Twin of the Ocean, the DTO program. And what happened was that Blue Cloud was very successful. At the same time, the Commission said we support the DTO program, and especially the EDITO project, or EDITO back office infrastructure. And they said maybe it's best if you merge in a way so that the Blue Cloud becomes the node in EOSC for the European Digital Twin Ocean, and is fully federated and merged with the EDITO. And this way, let's say, we can serve better the purposes of both EOSC as EDITO. Now, saying this, if you look at the strategic landscape, there's a saying, no more silos, but let's work together, let's merge, or let's work together. That was said by Nicholas Segerbart, who is also behind the EDITO program as one of the EU officers. And he was also at the birth of Blue Cloud, so he knows very well how Blue Cloud operates. And if you look in this landscape, there are several developments ongoing, but there are three main items that are interesting. One is, of course, the European Open Science Cloud. This has been maturing over time, and now they're working strongly on a federation of nodes. Then there is the EU mission, Restore Our Oceans and Water, and they need a lot of data and knowledge. And there is then the European DTO program with EDITO as the back office infrastructure, and that will support with analytical work. Let's say will support the mission, and also we work for the EOS Federation, bringing more science into the whole chain. But the challenge is, of course, to work together with these for these three items and targets. And the Blue Cloud has now positioned itself, like I said, as an EOS node, as a digital twin ocean, and we are more or less like a strategic and operational bridge. And we will represent EDITO in the EOS community, and at the same time, it can serve as an incubator for new ideas and new applications that then can be deployed also for in the wider EDITO community. Now, this is a schedule. Don't it's always nice, these schedules, but what we bring here is on the left, you see the EOS Federation, which consists of several nodes. Could be the EU node as a core, but there is also thematic nodes. There is also national nodes and nodes. Now, the EOS node for European Digital Twin Ocean is seen as a thematic node for the marine domain, and it has certain core engineering services, because that's every node should have those. And then it has some specialism, like a virtual research environment, and it has several virtual labs and workbenches, and also having access to a lot of data. And working together with EWNet and Copernicus, first of all, because they are also the EDITO founding partners, but also working together with several research infrastructures. There is also a cross-disciplinary use case, especially with life sciences, and that's there we look at biological sequestration of carbon in the ocean. And it means, in fact, that we try to see how two nodes, two thematic nodes in the EOS Federation can work together and then achieve synergy, but also cross-fertilization for better analytical results. If you look at Blue Cloud is not only developing and operating services, but also we have a training academy. And today, of course, is one of the webinars which is related to this. There is a website where you can find the courses that have been done already. And also there's a new one coming, which is in fact today, the marine environmental indicators. And there is more planned. And you can, if you follow this on the website, you can find what's further in stock. And then, of course, there's another thing is that we have let's say a special conference coming soon, 28th of May, open conference, where we present from Blue Cloud to the EOS node for the digital twin of the ocean. So the journey that we made, and also then all the services that have been developed, and we really welcome you, let's say, to join. And therefore, please go to the website of Blue Cloud and register so that you can be part of this. Could be both online as well as that you are in presence there in Brussels. I wish you a very good webinar today, and good luck with all your other undertakings. Bye.
Thank you very much, Dick, for your interesting presentation. And we move on now to the next speaker, which will be Francesco Palermo from CMCC Foundation, and he's as well the coordinator of the Marine Environmental Virtual Lab, Indicators Virtual Lab. So Francesco, please go ahead.
Yes, I'm going to share my slides.
Mm-hmm.
Can you see them?
Yeah, perfect.
Hello, everyone. Thank you, Dick, for the short introduction to the Blue Cloud project. I'm Francesco Palermo from CMCC. Today, I'll present you the introduction to the Marine Environmental Indicator Virtual Lab that started in the first phase of the Blue Cloud project, so 2020. And we improved it during this phase of the project and the Blue Cloud phase 2026. This virtual laboratory has the aim to provide some marine environmental indicators. It provides a powerful environment for monitoring and evaluating the environmental conditions of marine areas, offering essential support for decision making in ocean management. The virtual lab offers the possibility to using multiple data sources. And so it provides a unified data analysis services, and the users can use different tools for generating these environmental indicators. They can use Jupyter notebooks. In this way, they can also change the code, or they can use the dedicated web application that should be much easier to use. The virtual lab on page, users can access to the virtual lab after the subscription to the Blue Cloud. You can see here some URL that you can use for accessing it, the Blue Cloud on page and the VLab on page. When I show later after the presentation of the slides, I'll show you short videos for presenting the making you a real demo of this VLab. So from the home page, you can have access to the tools, so the notebooks, the web app, for the latest included indicators, but also for the others as well, the previous one, I mean. The new indicators are the ocean heat content, the tricks, and the marine heat waves. From the home page, users can access also the documentation that will be very useful for them to understand what are the scientific information about the indicators, the instructions, I mean the guide, the how-tos that they can use for understanding more how to use these tools. In the near future, I hope the OTGA course. So this is a few screenshots from the May generator web app. That is a web application that offers the possibility to users to choose of course, the indicator of their interest. It's called the method for selecting the algorithm. And the user can select what the kind of output type he needs. Some important parameters like the data source to use for generating the indicator, the time range, the area of interest, in case of 3D datasets, also the depth, and some other additional specific parameters. When user ends to select all this information you need for generating the indicator, he can submit the job to the cloud VRE, and the cloud-based computing will produce the indicator of interest. Here are some screenshots about the notebooks available for the marine heat wave, the tricks, and ocean heat content. The partners involved in this VLab are 4. CMCC is the leading for the VLab. There are 2 other institutional researching partners from Italy that are ENGV and OGS. And there is also the KNMI, which has been involved for the Storm Severity Index, which is based on the atmospheric data. indicator. What about the target users for this VLAB? It is designed for a wide range of users involved in marine environmental management. The key groups can be environmental scientists and researchers, policymakers, marine resource managers, the NGO or environmental advocacy groups, or academic institutions, university, but also general public and educational institutions. A few words about the importance of the indicators. Indicators can transform data into information for a scientific interpretation of the dataset, knowledge for the contextual understanding of trends, and at the end of the action, so policy and management responses. So this chain of data, information, knowledge, action is a backbone for marine environmental governance. That's very important. And with indicators serving as a bridge between scientists and decision makers. A few words about the indicators available now. So marine wave, that is an indicator that shows the period of abnormally icy surface temperature persisting for at least 5 consecutive days, relative to the varying 19 percentile threshold based on daily climatology baseline. So this is the definition of the day. The relevance is it's about the quantifies frequency, duration, intensity, categories of thermal extremes. It reflects ocean climate variability and ecosystem stress, and is used for monitoring, forecasting, and risk management with climate service. A few screenshots about the outputs available for this indicator that are the temperature, the map of the temperature anomaly, the map of the marine waves categories. They are divided by different level of category. The time series for looking at the evolution of the marine heat wave. Another indicator is the ocean heat content, which is defined by the amount of thermal energy stored in a given volume of the ocean, typically expressed as the vertical integrated temperature anomaly. It quantifies how much heat the ocean has absorbed over time. So relevance is it a primary indicator of global and regional warming? It used to assess the energy imbalance, climate variability, and long-term trends in ocean warming, and it's crucial for understanding sea level rise. It's a key variable for climate model validation and analysis products. The trophic index depends on the availability of nitrogen, of phosphorus, and phosphorus for primary production, which in turn determines the phytoplankton biomass and the oxygen saturation. In TRIX, the nutrients are represented ideally by total nitrogen and total phosphorus. Chlorophyll is a substitute parameter for phytoplankton biomass, as production is not routinely measured. And the deviation of oxygen saturation from 100% in the production layer indicates the production intensity of the system. Relevance about tracks and monitors eutrophication hotspots, which helps to detect early sign of stress and guides conservation efforts. Simplifies complex data by combining multiple parameters into a single score. Supports environmental policy to classify water bodies and enforce environmental regulation. This is a screenshot extracted by the simple interface that you find on the notebook. Last one indicator is the enhanced storm severity index, which is atmospheric in the end indicator. The calculation of the storm severity index indicates exceptional atmospheric wind circumstances with a high risk of severe impact. The relevance is the quantification of wind circumstances with high risk of severe impact, storm climatology for different areas and time periods, comparison of individual storm or storm seasons. A few screenshots taken from the notebook. This ends the presentation of the VLab. Now I'm going to show you directly how the VLab looks like with a video. So this is the, can you see it?
Not yet.
Not yet.
What we can see is the singing page of Blue Cloud.
Now you should see it. This is the Blue Cloud on page.
Yeah.
Okay. So from here, the user can register itself or sign in if you haven't already it's registered. Okay.
We see a white screen right now, a black screen.
Oh, sorry. I don't know what's happening. I'll try to share it again.
Okay, now it's working.
Okay. So after using the credentials on the Blue Cloud gateway, user can access it. He can register on the website or using other systems for accessing it. From the home page of the Blue Cloud project, you can access the different virtual labs available. We are looking for the marine environmental indicators. This is the home page of it, where you can find a shorter description and all the possibility to access to the services. I mean, the notebooks, the web app, and also the documentation, as I said before, presenting the slides. There are a different possibility to access the documentation. There is the user's handbook, which contains also the information, scientific information about the indicators. There are the short guides like the how-tos, and also the help on the web app, but also on the notebooks. Now I'm going to access the web application. From this, as I said before, user at first select the indicator, which is called here method. After choosing the method, on the generate new outputs tab, which is the first one. After producing the indicators, the users can see the outputs on the My Request tabs. There is also an help page that will be used for understanding more about how to use the web application. It's very easy. It contains all the information needed for understanding more about, there are step-by-step instruction for using the web app. This is after configuring the method, so selecting the outputs, the method, etc., the parameters, user can submit the job for generating the indicator. So I'm going to do that now, showing that. I'll select, for example, for showing you how the web app works. I'll select the marine wave. I select one of the outputs available, which is, let's see. Don't remember what I chose during this video, which is also available on the EuroGOOS course. And after selecting the output type, I can select also the data source, because there are different data sources available for the marine waves. There are the SST for satellite observation, but also the model data. So after selection output types, the 10 series, I selected the model data of marine of Mediterranean Sea. I select the climatology. Regarding the output, it's time series, so I can select the time range to the starting date in June 2025 and ending date for September or October 25. User can also select on the map the area of its interest. After all this, can also move on the drag and drop the cursor on the map, can change the area. After that, user can start to executing the process. The web app we call the data analytics of the Blue Cloud, and it will process the parameters inserted using the algorithm of the choosed indicator, and after a while, after the processing, user will see the outputs. On this page, user can see what is as submitted, what's the status of the job. Now it's running, which are the main parameters he used, like the area, the depth, which is not available here because it's a SST, and the time range. So, but it's parallel. So if user want to start to generate another indicator, he can. So he can go back to the first tab of the generating new outputs, select the storm severity index, for example, and select the output type related to that indicator, all the parameters needed, and then execute again for this, call the analytics engine for execute this new indicator. As before, in this case also can be selected time range and other customized parameters. Clicking on execute button, you will see the answer by the system that the job has been submitted, and the manifest user can take a look at what's happening. So the jobs are running, and they are computed by the CCP. Let's see what will be the output. Yeah. For example, take a look to the already produced output, like the SSI. From this page, this page for accessing the outputs, the user can download the outputs, can download the NetCDF produced, even some logs, text log he produced by computation. This is the example of the already produced Marine Wave 10 series, just produced after this submission. Okay. This is for giving you just a very short demonstration of the VLab and its capabilities. Thank you.
Thank you very much, Francesco, for this fruitful presentation and detail, and also to inform the participants that after the presentations of different speakers, we will have a section of questions and answers. But I see in the chat that Andy asked if the generated data can be cited in a publication, and if yes, what would be the website? So I don't know if you want to keep this question for later, or we can answer this right now.
Sorry, can you repeat the question? What it
Yeah.
was?
So the generated data can be cited in a publication, and if yes, what would be the website?
Oh, yes. Please give credits on that you have produced the data using the tools provided by Blue Cloud.
Mm-hmm.
And what the user, the VLab, provide information about the VLab use.
Okay, thank you very much.
Take a look to the homepage. Thank you. You're welcome.
Thanks. And now we are going to move to Lina who is the coordinator of BioEcoOcean. So Lina, please, you can share your screen. Thank you very much. Floor is yours. You are muted. You are muted. 1 second. Yes.
So, can you see and can you hear?
Yes, right now, yes, both of them.
Excellent. So, yes, just as Alicia said, my name is Lina Nordlund, and I'm very happy to be invited to this. And thank you for a very nice presentation about the lab as well. So, I will tell you a little bit about BioEcoOcean and what we are doing. So, this project is running for 4 years. We still have almost 2 years to go, and we are 9 partners. And it's funded by the European Union. So the ultimate goal with our project is to enhance BioEcoOcean observing capacity for advancing scientific understanding of the ocean and increase the utility of ocean observations. So we are really focused on the biology and the ecosystems. And I would say, or would argue, that we really need coordination and interoperability to advance our understanding of the ocean. But how do we do it? And one of the things that is really helping us to collaborate better and to become more interoperable is the essential variables. We can't measure everything at all times. It's just too expensive and too time-consuming. And in our project, we're focusing on the essential ocean variables, the EuVs, and especially the biological and ecosystem EuVs. So one of our project objectives is to really try to accelerate and improve the implementation and usage of EuVs for biology and ecosystems. And as we could just hear from the other presentation, we really need more biological data available, so that can also be integrated in, for example, indicators. So what are these EuVs? So the essential ocean variables are governed by GOOS, and they are a set of key ocean measurements that can really help us understand the ocean and its change. And GOOS recognizes 36 of these essential ocean variables. And if you would like to read more about them, you can scan the QR code. I will post the links also in the chat later. So it's a newly published paper really describing sort of the process of developing the EuVs. And as I said, in our project, BioEcoOcean, we are focusing on the biology and ecosystems. And one of the big things that we've been doing is to support the update and further development of the biology and ecosystem essential ocean variables, and especially the specification sheets. So each EuV has a specification sheet. It's sort of a recipe of what to do. It provides background and justification, applications, the phenomena to observe, data management and information, the actual observing specifications, as well as observing approaches. And this is sort of how they look in real life. And they can also be downloaded from the Global Ocean, the GOOS website. I will also share the link to that after this talk. So one of the key things here with the essential ocean variables is sort of these key measurements that then also needs to follow fair data principles, so that we can have our sustained monitoring data, all our observations being part of this shared data ecosystem. Because with more available data, we can also create very nice products. In this example, for example, a seagrass distribution map, but it can also contribute to different indicators. Some other exciting work, which I think also OBSI4CLIM will mention maybe in their presentation, is also a newly published paper led by Carina von Schuckmann about global ocean indicators, and they're building on the essential ocean variables. So I thought that was nice to mention, because I guess many of you are here to learn more about the indicators. I also put the QR code there to access that paper. So if we want to make indicators, if we want to really advance the digital twin of the ocean, we actually have to be quite mindful about where we publish our data, how we publish it, and what we publish. So the data becomes available following fair data principles and sort of contribute to this global digital ecosystem. And yes, we are in Europe, maybe, and this focus might be on Europe. But if you look at the Mediterranean, we also want data from the Northern African coast, right? And to ensure that this data is interoperable is, of course, very important. So, and I had a look at all these virtual labs in the Blue Cloud. I mean, there is quite a number of them, and I think this is quite exciting. And also showing that if we want to make a good use and have better accuracy of whatever we develop in these virtual labs, we need this abundance of data, right? So it's really key that we follow standards when we collect data, but also publish our data. And when it comes to physics and biogeochemistry, that kind of data is much further advanced, and it's much more readily available compared to the biological and ecosystem data. Another thing I would like to highlight from BioEcoOcean, as I mentioned first, we need coordination and interoperability, but how do we do it? And we think another thing that is very important is more consistent communication and collaboration among sectors and stakeholders. So we are developing, it's a framework, a support tool, and it's called Oceanis, and it's done through a co-creative process. And Oceanis is a general operational framework. It's question-based, and it can really support us to collaborate. It's developed to spark and encourage collaboration and communication across the sectors, and as well as sort of enable integrated approaches. So it's really something that anyone of us can use to support our communication and, for example, in the work of developing indicators. So the Oceanus, it's still in development, but we already have a quick start, and the planned launch is for autumn 2027. So the framework looks like a spider web, and it's really to showcase that everything is connected, and we really need to start working much more across different silos, cultures, sectors, and expertises, for example. And the spider web here is the core, but the framework also has descriptor words and the themes to really give more depth into the framework. And this framework is then combined with question words. And as an example, one of the components in the framework has descriptor words, it has the question words, and it has themes. And with the combination, you can really start thinking about things that you might not have thought of yet. And also, sort of the advanced version is to really start combining different themes, for example, exploration and societal relevance, and start talking across those components. And if anyone is interested to have a look at the Quick Start Guide, it's available here. Again, I will post it in the chat. But that's it from me. Thank you. And yeah, I think I'm here for questions later. Thank you.
Thank you very much, Lina. And now let's move on to the next speaker, which is Stephen Olsen. He is the coordinator of OPSI for CLIM. And we will go back to the questions I said before. So, Stephen, thank you. Perfect. And you are muted. Last thing.
Important too.
Yes.
Thank you.
Fantastic.
Yes, and yeah, thank you for the invitation, and thank you for a really impressive presentation from Blue Cloud. I'm the coordinator of OPSI for CLIM. We are focused on ocean observations and indicators for climate and assessments. It's a project which is totally aligned with Lina's project. We are just focused on the physics of the climate system and ocean monitoring and data. Let me see if I can get this to work. Our consortium is slightly larger. We have 17 European partners plus 2 Indian partners. So I basically stand on the shoulders of a lot of strong expertise and experts in this project. Some of them you will notice go across also to Blue Cloud. So some of what from our project is aligned and kind of work in parallel and complements what's being presented here from Blue Cloud. The overarching goals of our project is to deliver improved framework for nations' contributions to European ocean observing of EuVs and ECVs. We do that in support of regional and global climate assessments of projections and actionable indicators of sustainable development. So again, indicators is part of our concept. To the right here, you see a list of, just have to free some space here, of the structures and organizations we support and collaborate with, OPC, EuroGOOS, DCOS, Ocean Best Practices, and CMIP. Those were written into our proposal as structures we support. And to the left, you see some of the new policy developments that really aligns with what we're doing, the European Ocean Act, and most recently, the launch of the Ocean Eye. The project has a number of building blocks. We have identified initially 4 blocks of that we would develop our project on top of. That is the nation's ocean observing applicable to selected ocean climate application areas, which I will come back to. We base our activities on the established EuV and ECV framework by EuroGOOS and DCOS, and as well the Global Climate Indicator Framework, or a version of that, the Ocean Indicator Framework. Also, the Earth System Model and climate projections coordinated under CMIP is part of what we build on. So in short, if you want to ask what we are doing, then we are adding granularity and detail to the rolling review of requirements for ocean and climate applications, supporting the development of EuVs and ECVs. The rolling review of requirement is a process which is used by WMO and GOOS, and it's kind of illustrated by the circular graphics in the right here. It goes around reviews and statements of guidance, and you're welcome to look that up, but I won't have time to go into that in detail. What is important here is to flag for you the areas we're working with. These sub-application areas within ocean climate that we have identified as challenges to the observing system. That's the ocean mesoscale, sea level, marine heat waves, ocean stratification, ocean transport, and sea ice loss. Again, you notice marine heat waves at least as part of a crossover with what Lina presents and what we see in Blue Cloud. I have an extreme delay in shifting here, but I expect you see this slide here. Define the rolling review of requirements approach for GOOS and and in support of EuroGOOS and ECVs.
Mhm.
This is something we have developed. It's a robust and widely understood questionnaire and framework, which is basically targeted to streamline the collection and formalizations of observational requirements. There's a link here to the questionnaire that we have co-developed, and it's already been used, and I hope that it will be picked up by others in order to challenge and test the observing system and give robust advice to the structures, GOOS, GCOS, and WMO. And I'm trying to change screen again. Okay. A specific example of what we have delivered is a data density map, which is designed to improve the integration and accessibility of in situ observational data to support the creation of reliable EUVs. You may ask if this is not already existing in EMODnet, but no, we have had to merge a new data set, adding more detail in order to explore both time series and profiles in a consistent manner. This is also developed in a Google Colab, which you have the link to here, where you can go in and play with this package to explore different parameters, different regions, different scales, and see if there's data available from different monitoring platforms for your application area. We also work with best practices and standards for observations and for fair EUVs and ECVs. We have initiated a Ocean Best Practices Federated Network, which can draw in methods from repositories across Europe into one single user interface. We started with a conceptual design sheet to the right here, did a survey of European repositories, and a pilot for the user interface is in place already. Methods, best practices don't come out of data alone, so a lot of work has gone into to find the methods for underlying data put into the different data repositories. And we have been so lucky to get responses from a wide range of data providers. Best practices don't come alone. You need basically also to understand the maturity of ocean practices in order to rank them. So a lot of work, which is still ongoing and being structured, is interviews on recognized methods, updates of criteria for good, better, and best practices, and work towards endorsement of a model refined and the review with GOOS at present. I don't have to introduce indicators to you. This is the famous slide, which basically tells what it's about, but I want to highlight the scalability of ocean indicators as a part of what we are working with in OPSI for CLIM. An ocean indicator should be scalable, spatially, temporarily, and where possible, interoperable. One example of what we have been working with, a lot of curves here, I know, but this is basically a comparison of different EUV data sets for trying to understand something as kind of robust as the ocean surface temperature development. We are using different products, and we are looking into a global, an Arctic, and an Antarctic domain. One product which really stands out is a product in black here. That is the product that integrates ice surface temperature and sea surface temperature, where we see a strong difference between the other data sources, where basically the Arctic warming stands out as much stronger than you would otherwise observe in other data sets. So combining and generating new robust EUV data sets can be very important, not necessarily at global scales, but at regional scales. Frameworks and guidance for extreme indicators. That's the extreme extremes of UVs is something that we target specifically and have identified a need to set up a framework to structure the requirements that comes from extremes and what we need to focus on when we define extremes. You see a table here which goes across which indicator we are looking at, for example, marine heat waves on top, what UVs goes into it, the temporal resolution of data you will need, the climatology to consider, the type of climatology, and the methods, basically the thresholds for marine heat waves. So we have worked with that, kind of set up a framework for that across different extreme indicators, and that is work in progress and hopefully something that we can get others engaged in contributing to. An example of extremes, again from the Arctic, this is using the same data set I showed before, trying to map out how marine heat waves or the alternative cold spells has developed in the Arctic region in the historical period or satellite era. You see that we have a strong shift from basically cold spells to an Arctic which is dominated by marine heat waves with present definitions at least and climatologies, and that is something that we have contributed with to the AMAP assessment, the Arctic Monitoring and Assessment Program. Finally, ocean narratives. We see that as an integrative approach for ocean indicators. It's a concept which has already been introduced in the Ocean State Report by Carina von Schuckmann in 2025. And instead of describing kind of classically the state of the ocean in numbers, it's trying to provide some overlays to provide a policy-oriented graphics or context to discuss the for example, the planetary crisis, which is an example given here to the right, without going into specific numbers. We are in the project developing further narratives than those already presented here in the Ocean State Report, for example, focused on the Arctic region. With that, I will end and say you can visit our webpage, follow us on LinkedIn or Blue Sky. Thank you.
Thank you very much, Stephen. And we now move to our final presentation from the BioGOOS project. So I'm pleased to introduce Abed Hassoum, and he's currently leading a work on biochemical indicators in this project. So Abed, please.
I think.
And can I ask? Yeah.
Are you able to hear me?
Yeah, I can hear you, but I can also hear noise from someone.
Yeah. So. Okay, so are you able to hear me now?
Yes.
Fantastic. So actually, first of all, thank you so much for the invitation. And yeah, I'm not going to talk about the project, the entire project, like the colleagues, Lena and Stefan has mentioned their project, because here I'm focusing really on indicators and the work on work package 1, actually. But I would invite everyone who's interested to know more about BioGOOS to visit us in the website. I'm going to put it in the chat later on, because it's really also there are lots of overlaps and lots of things that actually might interest the audience here. So this is the youngest sister project, actually. And yeah, so I'm going to focus here on our work on indicators. So this is not only, I mean, an individual work, but it's a group work of partners and colleagues working in general, not just in the consortium, but also external experts working here with us in BioGOOS and beyond. So I'm not going to repeat actually what was mentioned by the colleagues about the definition of indicators. I will try to be super concise, but I would surely advise you to go to Karina's paper, von Schuckmann et al. 2026, in order to better know how we are actually, which framework and which definitions we are following. So in general, to be brief here, we are following this specific framework or definition that ocean indicators refer to measures based on scientifically verified approaches and data that allow for the identification of the state in ocean phenomena across a range of temporal and spatial scales that are accessible to inform decision makers and beyond. So the main, actually, let's say, pillars of the indicators we are trying to build, or we are building actually in BioGOC, they should be verified. So they must represent a state of an ocean phenomenon that relies on a peer-reviewed scientific rationale. They should be significant, providing robust information on the state of an ocean phenomenon. They should be scalable, should be like scalable spatially and temporally. They should be justified, so relevant to inform and support decision making. They should be measurable, determined where relevant. I mean, they should be relevant via like one or more essential ocean variable, or essential climate variable, essential biological variable, and they should be accessible. So that's it. And BioGOC indicators are explicitly designed following this framework. So what are the gaps in existing ocean indicators? Because this is our really main topic. Currently, we are seeing lots of fragmentation in indicators. So there are lots of indicators in the market, but we clearly see fragmentation in these indicators, but also lack of harmonization. For example, for me, I wasn't so aware of the Blue Cloud effort and the indicators, the marine environmental indicators that you are working on. And there is a clear lack of harmonization of efforts, that's for sure. Weak uncertainty treatment in general for indicators, for example, limited multi-stressor integration as well, and weak link to operational systems as well. And here in BioGOC, this is exactly what we are trying to address. So how are we doing it differently? So we do have like clear hierarchy from metrics to indicators to the composite indicator when needed and when it's possible. A process-based design, explicit equations, and uncertainty treatment. So we guarantee that there will be reproducibility and traceability of our indicators. Model observation interoperability, same formulations across both. And also multi-stressor integration that I will talk about later. So we are trying to, after the co-design process, we are testing and then we are validating. Then we will be working on the visualization and operationalization of our indicators, and then the dissemination to various stakeholders. But through all these processes, we are always doing a refinement for our process in general. So it is an iterative process, and that's the beauty of it. We are still in the now testing and validation process, so in many case studies. So again, this is part of work package 1 in BioGOC. Task 1.3, please, check our website. There are lots of useful information for you. So the 5 indicators co-designed within BioGOC are really related to 4 biogeochemical phenomena, mainly, which are ocean acidification, ocean deoxygenation, biological carbon pump, and the greenhouse gas fluxes. But we are also working on something more, which is the integrative indicator, integrated multi-stressor indicator as well. So I'm gonna very briefly, I will not detail here the formulations and the mathematics behind it, but just to give a brief documentation of what we are doing. So the objective of ocean acidification indicator is to quantify the rate, state, and exposure of ocean acidification across regions via core metrics, like trend in protons, for example, that's the acidification rate, trend in omega aragonite gasification stress, the mean, so to present the state or to have an idea about the state of ocean acidification, the extent of the saturation state of aragonite, etc. And also for ocean acidification, we are designing a composite indicator, so normalized, equally weighted, directionally consistent. So what are our advances? We adopt community standards and enforce project-wide consistency. For this indicator, we combine the state, the trend, the threshold. It's not done jointly before. And we explicitly normalize also in the indicator, and we calculate also, we are very clear in the uncertainty propagation, trying to be consistent across models and observations. For ocean deoxygenation indicator, we are trying to quantify the oxygen decline plus hypoxia expansion via core metrics like the trend in the concentration of oxygen vertically average, hypoxia fraction, with in addition to other optional metrics or diagnostic metrics as well. And also for this indicator, we are designing a composite indicator as well. And the advances are many. So we separate long-term trend and short-term variability. Also through, clear time of emergence approaches, signal-to-noise ratio approaches. We use standardized thresholds that are also highlighted by global and regional entities like EuroGOOS, HALCOM, OSPAR, etc. We include temporal dynamics, fraction of time under hypoxia as an example. For the third indicator, which is the biological carbon pump indicator, the objective is to quantify the magnitude and efficiency of carbon export to depth via a core indicator and a process decomposition via diagnostics metrics like the export efficiency, transfer efficiency, and attenuation, etc. So here, we are not developing a composite indicator because variables are physically coupled, and the composite indicator would cause double counting and loss of interpretability. So preferred not to do a composite indicator here. What are our advances in this project? You might ask. So we are defining single physically meaningful core variable. We are keeping diagnostics separate, no artificial aggregation here. We ensure compatibility with the CEMIP, so the coupled model intercomparison project that is highlighting that particulate organic carbon export, for example, at 100 meters. We are trying to be in line with these frameworks, and we work across models and observations and this indicator as well. For the greenhouse gases fluxes, the objective is to quantify the ocean atmosphere fluxes for carbon dioxide, methane, and nitrous oxide to assess their climate relevant exchange, to support budgets of natural and anthropogenic greenhouse gases. Also here, we are not developing composite indicator because they are direct physical metrics, so no normalization, no composite. So what are our advances for this indicator? It is salinity-aware Schmidt numbers here. We are using consistent gas transfer parameterization, harmonized treatment across the three gases that I've mentioned, and the uncertainty propagation also is aligned and streamlined across the project as well. And finally, the fifth indicator is the integrated multi-stressor indicator. And this is actually a product that we are trying to produce across the three sister projects. So BioGOC, together with the three sister projects that they were highlighted here. So to quantify compound ocean stress by integrating multiple physical, biogeochemical, and biological anomalies into a single dimensionless index. So why? Because, in many times, and we are hearing always from several stakeholders that one indicator might not be informative enough for them to take actions or decisions, etc. So, we are living in a multi-stressor world. So having a multi-stressor indicator would be really needed. So especially when it's founded on scientific ground, right? So this indicator provides a measure of cumulative environmental pressure, identifying areas where multiple climate risk drivers co-occur or interact. So also here we are trying to be consistent with international frameworks like the IPCC, for example. This is the first cross-domain indicator integrating physical, biogeochemical, and biological stressors in line with as I said, international frameworks. So this is just to summarize what is existing and how we in BioGOC are advancing what's existing. So for ocean acidification, for ocean deoxygenation indicators, they are fragmented, many metrics, of course, in the market. We are trying to co-design and to test, validate integrated composites indicators. For the biological carbon pump, there are multiple inconsistent metrics, and here we are trying to use single flux plus well-known and informative diagnostics. For the greenhouse gas fluxes, existing approaches are using flux estimates. What we are trying to do is to be harmonized and to be clear in terms of uncertainty. For the multi-stressor, we are developing a new indicator. So there are lots of here between BioGOC and what has been presented for the Blue Cloud, and BioGOC clearly through this work that we are starting here in Work Package 1, it can provide scientific backbone for the platforms like Blue Cloud for sure. So that's what I wanted to say. If you have any like questions or willing to have like any suggestions to improve, I mean, this is my email, of course, and here I can, of course, stop sharing and open the discussion maybe.
Yeah, thank you very much, Sabed. And before moving into the discussion, I would like to invite you as well to participate in the workshop that we will organize at the European Maritime Day. It will be the 22nd of May. And also to visit our stand, because we will have a stand together with the 3 sister projects. So now, yeah, let's go into the discussion. And I don't know, Antonis, if you want to read your question directly or... please feel free to yeah.
Hello.
Hi.
I was impressed by the work you've done on VLab. I was wondering what's the future of it, if you're going to add more computing power for inference of AI models. And basically the second part was about new projects that could be imported into this VLab, so new applications could be imported. And how is the server going to be up all the time, or about the funding of the servers?
Okay, I'm getting. Thank you, Antonis. Thank you for your compliments. The Blue Cloud 2026 will continue in a new project that will start in a few months. The aim will be to include the Blue Cloud inside the EuroGOOS platform. But I don't know. I don't know if there are already available GPUs for making calculation inside Blue Cloud, because we used notebooks running on the Blue Cloud VRE, which is the cloud platform on the Blue Cloud, but also they are also available on the Google Cloud. And just I want to say also this. The interaction with the submission of the jobs from the web app is using a Blue Cloud service, analytics service on the cloud, which is specific for Blue Cloud. It is organized using a Docker container. So each job submission will be submitted as a Docker container on this cloud platform. So for the next, I don't really know what will be the evolution for the next phase, because I don't know really if we are going to introduce new processes or application. I don't know yet, but we will see.
Thank you very much. And
Thank you.
Massimiliano, you had your hand raised.
Hi. Yes. Just to complement on Francesco's answer about the GPUs. Sorry, I didn't introduce myself. I'm Massimiliano Assante. I work for CNR and I lead the work package for the VRE in Blue Cloud 2026. About this GPU availability, we have a few resources available in this sense. In particular, in Blue Cloud, we have a partnership with Google Cloud Platform. And so there we have some NVIDIA V100 CPU available. Yeah.
Thank you very much. Any other questions for our speakers? I saw that Dina answered some of them in the chat and she included as well the links.
I do have a question.
Yes.
Francesco, so are you open to the idea actually to like operationalize existing indicators on a Blue Cloud? So we in BioGOC, the intention is to visualize our indicators on our platform that will be created for our project, etc. But I mean, in the future, are you open to the idea of like featuring additional indicators that are not existing in your cloud, for example?
Thank you, Abed. Let's see for the next phase of the Blue Cloud. I cannot answer right now for this, for the evolution, I mean, for the evolution of it. I mean, I don't know, I said for the Blue Cloud, but the next project will be a different name, but will be the prosecution of it. You talked about the operationality of the services. At the end, they could be a draft version of operational indicators, because the way the web app is using the Blue Cloud services, it's a form of the could be used programmatically using the REST API. So the indicators that are running on the cloud services of the Blue Cloud can be, in particular for the Marinit waves, they could be already used as an operational service. That will be even improved in the future, I guess. I don't know if I answered for your question about operationality of the indicators. The possibility already is for it, but even for the Blue Cloud platform as it has been designed and the cloud computing services. I don't know if I answered. Thank you.
Thank you, Francesco.
So I don't see any more questions. And as indicated before, I invite you to attend both the Blue Cloud conference, as Dick mentioned at the beginning, also to register for the EuroGOOS International Conference, which is happening in Cyprus this year. And I invite you to participate as well in the workshop that we are organizing during the European Maritime Day that I share with you here, as you can see. So the registration for the European Maritime Day is open until the 10th of May. And I would like also to thank you very much for your presentations, for your insightful projects and virtual lab. And I will share with you the presentations of the different speakers, and the recording will be available as well in the Blue Cloud website. Thank you very much to all of you for today's webinar.
Thank you again.
Thank you all.
Thank you.
Thank you.
Bye.
Bye.